G7C, receivers and transmitters, filters, and oscillators. Which of the following is used to process signals from the balanced modulator and send them to the mixer in a single sideband phone transmitter? Did you ever imagine that those words could be put together in that manner? Let's take a look and see what they mean. Okay, here we have a basic single sideband transmitter, and it has a number of circuits in it, and we're going to process the signals from the balanced modulator, which is right here. This is where the single sideband signal, or actually a double sideband no carrier signal, is generated here, and the filter takes off the undesired sideband. Okay, so which of the following is used to process signals from the balanced modulator and send them to the mixer? It's a filter, which takes in the double sideband that was generated in the balanced modulator, strips off the sideband you don't want, and then it goes on to the mixer where it's brought to the operating frequency, amplified, and transmitted. So correct answer there is filter. Which of the following is used to combine signals from the carrier oscillator and speech amplifier and send the result to the filter in a typical single sideband phone transmitter? Here's our typical single sideband phone transmitter again. And which circuit is used to combine the signals from the carrier oscillator? Here's the carrier wave oscillator right here. Okay, and the speech amplifier, that's right here, sending us an audio signal into the balanced modulator. In the balanced modulator, we put in the carrier frequency, we put in the audio frequency, and we get out an upper sideband and a lower sideband signal. Okay, and then the filter, like we talked about in the last question, the filter strips off the one we don't want. So the circuit that combines the carrier oscillator and the speech amplifier is the balanced modulator. What circuit is used to process signals from the RF amplifier and the local oscillator and send the result to the IF filter in a super heterodyne receiver? We're in a receiver this time rather than a transmitter. And we're going to process signals from the RF amplifier and local oscillator and send the result to an IF filter. Okay, here's the RF amplifier. We have signal coming in through the antenna here, being amplified here. Okay, and we have a local oscillator here that's feeding a signal into this device. So the RF amplifier is feeding a signal into this device, and the local oscillator is feeding a signal into this device, and this device is a mixer, which changes the frequency of this signal to the correct frequency for the intermediate frequency amplifier and filter. Okay? Correct answer to that is a mixer. What circuit is used to combine signals from the IF amplifier and the BFO, which is a beat frequency oscillator, and send the result to the AF amplifier in a single sideband receiver? Okay, here I've only reproduced part of it so I can make it bigger for you. But here we have the IF amplifier, and it's amplifying the signal, filtering and amplifying the signal, and it comes into this device here. Here we have a beat frequency oscillator, which also feeds into this device right here, which then feeds the signal to an audio frequency amplifier. Here they're using an audio filter and then the amplifier, but same principle. That device is called a product detector. It's called that because the output here is the product of the IF amplifier and the beat frequency oscillator. The two of those go together to produce this audio signal. Which of the following is an advantage of a transceiver controlled by direct digital synthesizer? A synthesizer is a frequency generator, and it's extremely accurate. It is crystal controlled, but it has a wide range of frequencies that it can generate, so we're able to get variable frequency with the stability of a crystal oscillator. Now, an ordinary variable frequency oscillator that's not crystal controlled can drift with temperature changes, drift as components in it age, and so on. But the direct digital synthesizer is locked to a crystal oscillator, which is highly accurate, and so it lets us generate variable frequencies, but with the stability of the crystal oscillator. What should be the impedance of a low-pass filter as compared to the impedance of a transmission line into which it's inserted? You want to keep impedances as nearly the same as possible always when you're going through transmission line from a transmitter to an antenna. So about the same is the correct answer. You want the impedances to be as nearly the same as possible all the way through that system. And you'll remember the reason for that is that if the impedance is matched, then we get the maximum power transfer. We dealt with that, I think it was last week, possibly the week before. What's the simplest combination of stages that implement a superheterodyne receiver? Okay, the simplest combination of stages. Here's a superheterodyne receiver. It has a bunch more than the simplest, but basically for a superheterodyne, you need a local oscillator, you need a mixer, and you need a detector. Okay? Now, that's going to be kind of a crummy receiver, but it is a superheterodyne receiver, and it does meet the requirement of everything that's needed for a superheterodyne. Without an RF amplifier, the sensitivity is going to be poor. Without intermediate frequency amplifiers, the sensitivity will also be poor. And without an audio frequency amplifier, the output signal will be weak, and you may have to listen to it on headphones instead of a loudspeaker. So we put these other circuits in to make it a better receiver, but the bare minimum for a superheterodyne receiver is local oscillator, mixer, and detector. What type of circuit is used in many FM receivers to convert signals coming from the IF amplifier to audio? The demodulator, which is what we're talking about here, the demodulator in an FM receiver is called a discriminator. The demodulator in an FM receiver is called a discriminator. Which of the following is needed for digital signal processor IF filter? Let's look at how it works. We have an analog signal coming from, probably coming out of our mixer, or maybe coming out of an intermediate frequency stage, amplifier stage. We go to an analog to digital converter, and then here we have a digital signal coming into our digital signal processing here, where we can manipulate the signal mathematically in the digital signal processor, and then it goes back out to a digital to analog converter, and we have an analog signal again, which is what our ears are able to deal with, okay? Our ears cannot deal with this stuff here. But the signal processing circuits can deal with it very well and do a good job. So what do you have? Which of the following is needed to make a signal processor IF filter? You need an analog to digital filter. You need a digital to analog converter, digital to analog converter, and a digital processor chip. So A to D, processor, D to A. Okay? How is digital signal processing filtering accomplished? And as we just saw, it's done by converting the signal from analog to digital and then using digital processing. And the beauty of the digital processing is here we're all doing everything with the ones and zeros in there, and it can be done mathematically in here by the way the microprocessors that are involved deal with the elements of the signal. What is meant by the term software-defined radio? A software-defined radio is a radio in which most major signal processing functions are performed by software. In other words, basically, the much of the guts of your radio is a computer that's running a particular kind of software that does the various processing that you need. And if you look at some of the really small radios on the market, especially HF radios, like the ones from Elitech and some of the small ones from Yaesu and ICOM and so on, those are essentially software-defined radios, even if they have all of the operating controls of a traditional radio. Now, some SDRs actually are just a black box that hooks up to the computer, and everything is done on the computer screen and keyboard to do all of this signal processing. So there's kind of a range of software-defined radios also. But and what they're often talking about here is the black box that hooks up to the computer, software-defined radio.